Hello everyone, welcome to my YouTube channel Precision Manufacturing System. I'm back with another interesting video regarding the additive manufacturing process, especially about SLM process. And in our previous video, as you can see here, we talked about the single layer deposition of metal in metal additive manufacturing. But today I'm going to talk about actually, as you can see, this is related to our previous video, and in the previous video we talked and discussed about how to simulation the single layer for metal additive manufacturing. But today I'm going to talk about how to simulate the multi-layer of SLM process for metal additive manufacturing. If you haven't seen my previous video, I recommended you please watch that video first, and then once you got the fundamental actually knowledge about this kind of simulation, you can easily find the solution for this kind of simulation. Okay, let's get started for our second tutorial about the SLM process. But before starting, I really grateful if you could subscribe to my YouTube channel and hit the like button and stick around until end of this video, and introduce our channel to your friends and colleague, or whoever you found or you know this kind of video is helpful for them. Okay, thank you for your attention. Let's start the video. I'm going to make a copy from our previous model and name it multi-layer. Okay, and I'm going to do the rest of the simulation on our new model. I will start from the assembly, and I will import another layer, the second layer. Okay, and just transfer this layer to slightly top of this layer. Okay, this would be 25. Sorry, maybe. Okay, this would be 25, and this would be 4, and I will put slightly top of this layer. Okay, let's see. Yeah, it's okay, and I will use transferring face to face. Not this method. Yeah, this method. Select the face movable face instance, this one, and then select the fix, this one, and then I should select the axis and y axis and flip the vector for displacement, and just see the result. Yeah, it's fitted and matched with our the single layer. Now we have two layers of a cylindrical metal additive manufacturing. Then after that, we need to add our layer, our steps for depositing each layer, but we need to decrease the time of the cooling for our first layer. Let's put 50 50 for this one and 25 here. Okay, and then we need to add eight layers and more for our second layer, because we have eight pieces and or sections that we need to deposit in each step. So let's create the layer here and heat transfer time 5 minus 20, and this would be 2.5 and 350. Okay, we should create rest of the steps exactly like this one, and I will pause the video, and after making the whole layer I will back to you guys to make shorter the video as I can. Okay guys, this is the 8 steps for our second layer, and then we need to create another more steps for for our final cooling, and let's put the time 150 and here 0.01 e minus 20, and here 75 350. Okay, the steps was completed, and as you can see we have 8 steps for our first layer and 8 steps for our second layer. Okay, let's to do the mesh part for our second layer, and we don't need to create or meshing again for our second part, because we just insert or import our second layer from our first layer, and it's somehow our first layer and we did it before. So if you don't see our first video, please first watch our first video regarding the single layer additive manufacturing simulation in Abaqus. Then you can easily find to do the simulation for the second layer. But for our second layer we need to define sets as we did for our first layer, and for that one exactly we will do the same procedure for as we did for our first layer. Let's do that, and set 1 layer 2, let's put like this one, special layer 2, set 1 and element, and I will put cell here, and before that we need to do that, first select this one, let's make sure, yes, select this one and this, and then create set layer 2, set 1, select element, and continue, select drag all, and OK. Then for the second layer, the second actually section, we need to click this and select the second section, sets, layer 2, sets 2. OK. Let's rename this one to have a consistency between the name layer, and then for the third one, this one, and layer 2, layer 2, sets 3 element, and then drag. Okay, and let's create for the 8th section. First, select the section and create element layer 2, sets 8, continue, select, OK, and then we need to create all for 2 layers. Sorry. Okay, 2 layers. Right, and OK. Continue this. Okay. Okay. We did it, and we create all sets that we need. 8 sets for 8 sections, and one more layer for all 2 layers. And then we need to modify our interaction module and add some actually model change function for our second layer, then and also do some modification for our surface radiation and film. Okay, let's do that. And for this one we need to create and model change. Let's put it interaction 10 and step 11, reactivated in the system element, and let's choose the layer 2 and set 1. Okay, then again for the second should be 12, element deactivated, and for set 2. Okay, let's for this last layer of the second layer, last section of the second layer, and step 18, model change, deactivated. Sorry, we should put on no element and select the last section. Okay, for layer we need to change it to sorry, yes, yes, make it smaller, and then we need to hold the shift key and select these surfaces, and also for radiation again hold hold shift key and select these surfaces. Okay, and the important section here, you shouldn't forget the first, the birth and death steps, and you should change it to all two layers because we don't have any layer at the beginning of the simulation. So at the end of the interaction you should have such a this definition for your actually parts, and then we need to create tie constraint between two layers. So let's create a tie. First I want to choose this first layer and tie constraint node region and select one by one, or you can drag it and then select the second layer and again because this cylindrical and we don't have any partition for the to make a partition and segment in actually x direction. So if we select all points of these cylindrical parts, it's fine, and it will be defined for our model. Okay, and after that, I think only one part is left to be done, and that is defining the load for the radiation. So we need to again define eight load or steps like this one for our model. The first layer will be started from here, and the last one will be finished here. Then we will continue our model and again start from here to have a deposition for our second layer. Okay, let's start and create a load load 8, and we should select step 11 and surface flux, and create a select the surface, and 1.249933E7. Okay, again, should please don't forget to deactivate this for other steps. Then create the steps for the second section, 10, and step 12, second, 1.24.3.7. Okay, okay, we defined the 8th more load for second layer, and this should be like this one, our definition for load and radiation, and it's related, each load related to each section deposition, like this one and this one for the second, third, fourth, and until the end, like this one. Okay, let's uh, submit the job, and then I will back to you guys after once the job was completed. Before let's create a new job for this new simulation, and use multi CPUs and submit the job. Okay, we got an error. Okay, let's rename it multi-layer. Okay, submit. As you can see, the simulation has just started. I will back soon to you guys once the simulation was completed. Okay guys, the simulation was finished, and it was successfully finished and completed. Let's see the result. Okay, let's put mesh and normal temperature, first layer, and reduce a little much here, and yeah. Okay, the first layer is being deposited, and then after cooling, the second layer has been started to be deposited, and let's see in this view, second layer has been completed. Thank you so much for you guys for being supportive and support our channel, and be with me until end of this video. Please share this video on our channel tutorial with your friends and colleagues, and introduce our channel to your friends. And also don't forget to subscribe our channel and be a great motivation for us and our group. Thank you so much. Thank you for your support. See you. Bye bye.